So hello everybody, thank you for coming out and listening to me waffle on for the next little while about sustainable data. So I guess, what is it that sustainable data means to us? So we as BP, we're an oil and gas company historically, and obviously we've got an aim to be net zero by 2050 or sooner. So with that, we have a responsibility to people, planet, society, and we've got a set of aims that are our guiding light. And of course, well, there's going to be a URL and a QR code for you to scan at the end if you're keen to find out more. And of course, all of this needs to be done in a safe and responsible way because we are in a regulated environment. And data, of course, plays a key part in keeping us all safe. As Miles said, my name is Bergen, Larsen, and I'll be speaking to you about responsible design for and using data. So, BP obviously has a lot of data. Where does it all come from? So humans, obviously, we certainly process stuff, we capture stuff. We've got a whole lot of robots that go into places where humans can't necessarily go or shouldn't go, but keep humans safe. And these robots have sensors on them. And then all the equipment that we use to extract hydrocarbons, or even track solar panel output generation or whatnot, all of those things have sensors on them. So there's a wealth of data that's coming in and flowing into us all the time. In addition to all of this, there's joint ventures. So it's a very, very expensive industry to be in. So if you want to drill a well, or if you want to start a wind farm, or any of those sort of things, often you end up needing to partner with another company to split the risk. So you end up having joint ventures. Similarly, we have mergers and acquisitions. So obviously with our aim to be net zero by the 2050, we are actually helping certain small startups become really big overnight with our scale. So two key examples of that would be BP Pulse, which some of you may or may not know. The BP Pulse is an electric car charging sort of infrastructure. It started off, I believe, in the UK, and right now BP Pulse has expanded all the way across from America all the way through to China and a lot of places in between. And of course, we've also got a newish acquisition, BP Lightsource, which is basically helping solar panel rollout. So we're getting lots of nice renewable energy to help charge all those electric vehicles out there. So as you can imagine, with mergers and acquisition, there's a lot of data that comes along with that. Of course, there's also suppliers that help us actually do things. So people who manufacture wind farms, people that go out and do sonar surveys to basically figure out what's underneath the earth. So they have their own robots, they have their own drills, they have their own all sorts of bits and bobs that has data coming in, flowing in. Of course, sometimes there's gaps in data, right? And this is where third parties or analysts actually end up filling in certain gaps. And then, of course, the government in almost every sort of corner of the globe collects a whole lot of data. So we have a lot of data that we have access to, and we generate and correlate. So you can imagine this is quite big. So I guess with data formats, right, what does this mean? There's a number of different formats that data actually comes in. So you'd be surprised at just how many people out there still like a classic pen and paper. And convincing people to move from pen and paper is a challenge in itself. And then there's all the fun things of, does that pen and paper actually last in a really windy environment? And what does that mean if we transfer it onto a tablet and someone's wearing massive gloves and it's in the deep ocean where it's windy and horrible? So yeah, we've got a transition off paper, there's PDF, there's CSV files, there's Excel, there's structured data, there's unstructured data. And as soon as someone selects file, save as, that's just yet another drop of data that goes into our massive data lake. So our business is huge, in case you haven't picked that up yet and I haven't said it enough times. And so is the scope of our data. We've got everything from retail stores out there that are sitting on our forecourt. So we've got to track what inventory is in stock, what we need to restock, what sells out quickly, what's expiring, what's not. Of course, we've got all our old historic oil and gas business, right? So we've got a lot of people out there figuring out how to get to the stuff underground, how to do it safely, and then actually executing against that. Then we've also got all of our new ventures, which I spoke about earlier, so our EV charging, solar panels. We're also partnering with the UK government through some carbon capture and storage projects, so we're helping raise trails there. And of course, there's a whole lot of support areas behind the scenes. So what does that actually mean for all the people that actually need to produce it and consume it, right? There's a myriad of different systems out there that people are accessing. So if I just pick on weather, for example, you'd be surprised in a company like BP, we track weather, but this is a very important thing because we've got to make sure that people that are sitting out on rigs are absolutely safe. So if we know that a hurricane's coming in, we can prep and do all the things necessary. That same weather forecast can actually help us predict whether or not we'll have a good solar yield for a solar farm. So it's tracking all kinds of things and it's going from one use case to the next use case. And of course, all of this data comes in all kinds of different flavors. And of course, there's that wonderful system called Excel that seems to rule the world that everyone defaults to when they're in a bind. So let's talk about data management for a moment. So what we basically have in our organization is, and I've said it quite a number of times, there's a large quantity of people that are coordinating all sorts of things in this space. So a number of teams focus on helping to agree formatting, implementing that formatting, or the standardization across data standards. They help consolidate all the data into central spaces. They help get it from JVs and suppliers. They start repackaging it so that it can actually be transferred from one system to the next system. And of course, all of that, there's also teams of people behind the scenes trying to actually digitize this automatic data handover points, so there's less human intervention between it. Of course, in a company our size, there's a very real desire to basically leverage all the learnings and efficiencies that data brings. So if I talk about accessibility and access, so yeah, data needs to be available. It needs to be available for multiple disciplines and multiple different places. So often we do need to repackage it, as I kind of mentioned. So it might come in from a supplier, you might need to have columns rearranged if it's in a CSV file, and there's a lot of manual sort of intervention that kind of takes place with that sort of stuff. But then there's also not just that, we've also got to actually understand, well, what does this data mean? So sometimes you have to merge multiple different pieces of data together. So what we've sort of talked about there is basically it's the metadata, data that describes data. So if you're looking at a core sample of a bit of rock or a bit of earth that comes up from drilling, it's pretty useless on its own. Like, it's good to know that it's clay and it's, this permeable and that permeable, whatnot goes into it. But unless you know where it was dug, what depth, what pressure, all of that is actually useless. So you do need to make sure that you've got all the metadata in place to actually describe that. So not just talking about actually accessing the data in the different systems and being able to make data available where it needs to be made, people also need to be able to access it. And in some cases, you need to prevent people accessing it. So there are regional spaces in our organization where, for example, people in the US may not access data that's produced in Venezuela. So there's all kinds of fun little holes to trip through while you're trying to make data accessible in all sorts of fun places. So I guess the other thing that we've gone about understanding is how do we actually use this data? So in BP, there's a massive focus on safety. So we use data to de-risk our investments. We use it to ensure our people are safe. So I've used the example of weather, just making sure that all our colleagues are safe. It's hurricane season at the moment in the Gulf of Mexico, so we've got all kinds of safety systems out there for our colleagues onshore, never mind out on rigs. Yeah, we also use it for prediction. So again, using that example of weather, if we're able to study weather over time and track it and hold on to it, we can then start predicting whether or not a solar farm will be viable in a certain area, whether it'll actually be worthwhile investing in. Similarly, for maintenance purposes, if we put up a giant wind turbine in the middle of the ocean somewhere, we need to be able to track what actually went into it, what were the part numbers, was there anything on there that might be at risk for recall, so we know which vendor supplied which particular parts, where, when, how, who. And then we can also track that over time to see what is the average lifespan of this component, whether it's a valve sitting in a well holding hydrocarbons in the earth, or if it's something on a wind turbine that just needs replacing because it's got a 5-year lifespan. And of course, decisions. We live in a very interesting space in BP. We've got assets that we sort of have that span decades. So this data doesn't just need to live for today. Basically, we need to understand, if I take the example of a well being drilled for oil or hydrocarbons or geothermal, that well, specifically with hydrocarbons, it can take about 10 years to go from a sort of investigation phase to actually getting funded and actually drilled. Once they give the approval to drill, then that's roughly between 6 months and a year. Then that well will be in operation for anywhere up to 30 years. And then that well can again be repurposed and for carbon storage, or it will be plugged up. And at every step of the way, whenever there's an intervention, so the well's not producing as fast, or we need to replace something, that's new data that's coming in all the time. Cool. And then, of course, there's compliance. I think I'll touch on compliance in a moment. So, as I was also alluding to in the previous slide, data is very much alive. It morphs and it changes over time. And we have to have the ability to keep it updated at any point in time. New data comes to light at any moment in time, so we need a robust system to be able to notify people when there's a change in data. That helps us keep people safe in every aspect. So it's really easy for data to get out of sync quite easy when someone hits file save as and it's on their desktop. Right, so the other thing that we also need in this space is digital twins. So if we've got an asset out there that's busy producing electricity, whatever it might be, we might want to sort of track its data, and once we've got a digital twin, we can actually then run models against it to try and actually optimize its performance. So whether it's tweaking the angle, pointing towards the sun, pointing for solar panels, or changing certain valves out on a hydrocarbon well, this gives us a lot of lessons and a lot of analogies. We can learn from different areas across the globe if we've got access to that data. So I suppose the flip side to data changing all the time is we need point-of-time records. As I mentioned earlier, we're in a regulated environment, and not only that, we've just got a responsibility. We need to make sure that we're keeping us all safe, right? And with that, we need to understand at any point in time what was the decision made, why was it made, and what data went into making that decision. So, for example, just to be able to grant a license for either a solar farm or a wind farm out in the ocean somewhere, we need to be able to provide all the sort of long-term data that we've been collecting and storing, and actually be able to showcase what we were able to do. So with our scale, obviously we're accountable for ensuring we're safe now and also in the future. So internally we've got a compliance framework called the Operation Management System, and this helps keep us all safe in a very sustainable way. It's systemic, adaptable, and also consistent across our organization. So as you can imagine, we're operating in a number of different countries and a number of different regions. And that means that we've got a whole lot of regulators and we've got a whole lot of legal compliance that we've got to comply with. So this operational framework actually helps to keep us all in line and safe and meeting all the different points that we need to. Right, so with the scale of our data and the size of the organization, it's really important for us to actually orchestrate all of this. So there's a number of different handoff points which require a lot of governance. We need a whole lot of discoverability and access to be able to get hold of that data. We need to be able to track quality across the life cycle of the data. We need telemetry about who's using that data, where they're using it. We also then basically just need to make sure that this is all well orchestrated and governed. So with that governance, we need to understand who's accountable, and they need to help enforce all the standardization and just keep things running like a well-oiled machine, and that takes a lot of effort. Right. So it's vital that information is well orchestrated so that it will arrive in a state that is consumable, actionable, and timely. So I guess we've got a site up in the northeast of England called Teesside. This is currently in planning and subject to investment approval and all sorts of permitting. The site is about 4,500 acres, so for those tennis fans out there, that's about 72,000 tennis courts worth of space. It's a brownfield site, meaning that it was previously developed and is currently in a state of decay. And basically, the aim with this project is to try and inject some new life into the area. And this, we're hoping, will be a home to a whole lot of diverse, low carbon energy activity. So one of the objectives of the site is to actually have a carbon capture state where we're going to capture gas directly from a gas-powered station and pump that into a carbon store under the earth. And the aim there is to store roughly about 2 million tons of carbon per annum. There's also wind farms in the area, so the government is increasing its offshore capacity from, I think, 6 gigawatts at the moment to roughly, I lost my place, 50 gigawatts by 2030. So BP is working with partners and to progress the planning on offshore wind farms to help actually meet those targets. And to give you context, one wind turbine is able to actually produce enough energy to power 750 average UK homes. So that's a lot of power that's going to go up there, and that's 2.3 megawatts per wind turbine. So 50 gigawatts is quite a lot. Then there's also hydrogen production. So Teesside is one of these wonderful places where we are basically going through final investment decisions at the moment, and that we're going to be the aim is to transform the region and actually supply up to 1.5 gigawatts of hydrogen capacity. So that's approximately 15% of the government's planned target for 2030. And then BP also in the area has also partnered with Redcar and Cleveland College. So they're aiming to address the skills gap to basically help with an energy transition. So I suppose this site itself is one of those great examples of there's a number of different components happening here, where you've got a huge amount of data that will be flowing across multiple different disciplines to actually keep this area running and actually producing energy, capturing carbon, and supporting the community while we're there. I think to kind of explain the images, so on the left-hand side, these are actually core samples that I was kind of alluding to earlier. So this is actually from that Teesside site where they've been doing some drilling to see where it's feasible to actually store carbon. And I believe they also do that to actually help make sure that the buildings that they build in place are actually going to be sustainable and not sink and do all sorts of other horrible things. And then there's a site layout, and then I believe that's actually hydrogen storage facility that's on the right there. Cool. So I guess takeaways from my talk. So for me, the things that I've learned about data and trying to coordinate everything in the space over the last sort of year and a half that I've been in there is there needs to be trust in data. And to build that trust, that needs quality, and to understand what quality means, you need to work with your business stakeholders and actually create transparency through making sure that they understand how you're measuring that quality. And then standardization, so data needs to actually just be consumable in multiple different systems. The best way to do that is standardization. Especially in a global organization like ours, we have people moving from region to region. So if you move from one region to the next, and they've got different ways of doing things, it's quite difficult. So data should also be system agnostic and accessible in whichever system the end user actually needs to consume it in. And wherever possible, it's best to use open industry formats to actually take advantage of this data portability and minimize the friction points. And of course, this won't happen magically. One of the key lessons that I've learned over this time is data governance is a really key thing. That means driving the accountability, ensuring someone's got ownership, enforces the standardization, and helps drive data quality and prioritize interventions. So this basically boils down to the experience of consuming data. It needs to be very well coordinated at a strategic level and understood at a low level of detail at points in the journey where that data is consumed. So this talks to service design, it talks to research, it talks to product design for those in the moment. It's a huge, huge space and massively complex in this organization and ever evolving. Good. And with that, thank you so much for listening to me talk. My name is Bergen Larsen.
Thank you. Thank you very much. Yeah, please put your hands together for Bergen as the exit. We have a couple of minutes for some questions. Does anyone have a question? If you want to pop your arms up. Awesome. Someone's going to run mic to you now.
Thanks so much. Do you share any of the data for the public?
There is actually data that does get shared via government portals, classically, but yes, it does vary what data you're asking about.
Well, what do you have?
A lot. But yeah, I think it's best if you take a look at the government websites. We actually do also have industry reports all over our bp.com websites, so on there you'll find a large access to whatever data is freely available. So it does require a little searching.
Depersonalized, and if you're using it for public consultation, it's not attached to any.
Yeah, no, we don't deal with anything with personal information at all. So yes, everything would be depersonalized or specific to a project for public consultation or.
Thank you.
Sure, no worries.
Thank you for your question. We've got another one at the back here.
Thank you. Very interesting case study. I was wondering, when you were gathering these data requirements, were they used for any input on, let's say, creating internal tools to share this data? And if so, when you were collaborating with product designers, what tools were you using to communicate this complex data requirements and complex data structures?
Yes, very good questions. Short answer is yes, we used it to create products. Yes, there's a large number of different users that we are almost visualizing the data for. Some of them are off-the-shelf tools that we're using. So big suppliers, Halliburton, Schlumberger, like Go Search Oil and Gas tool sets, I'm sure we're using that somewhere. And then there's internal created tools. So I guess, yes, there's a number of different sort of case studies, and I think we've got researchers here, I don't think we've got product designers, but they're floating around in the audience, some of the BP staff. So yeah, I think like there's a large reliance on like Power BI, for example, to surface some of the data and do some analysis there. So that's interesting and challenging because we can't really work with any sort of design systems per se, but we can use what we've created in terms of our guidelines to influence those designs on Power BI dashboards. And similarly with Salesforce, there's some Salesforce applications floating around there. And then, yeah, there's bespoke systems. I think, if memory serves, there was a slide that I saw just when I joined about 2.5 years ago, which was talking about the number of systems that BP has across the globe. And it was some ridiculous number, like 1,500 or something systems. So keep in mind, you've got everything from point-to-sale systems in the forecourts to large 6-panel screens that people are using to track finance and sort of sell commodities. So there's a lot. And yes, there's a lot of product designers having a lot of fun with data at the moment. But then there are science